sharing my screen as well. So, okay, so is my screen visible?
Yes.
Yes.
Okay, so just a heads up, I usually, it's not on purpose, but sometimes it seems small, but it's actually bigger than I expected in terms of the material for the content. So again, for the nth time, uh, a bit something larger than I can actually chew. But let's see how far we get. Okay, so so the idea for this presentation actually came from Aziz, because I mean several times he kept asking me, "Hey, how do we create an API? How do we create an API? How do we create an API?" So this time around, I was like, "Fine, let's do it, but let's do it in a way that we take away the magic." You know, the reason why I say that is because creating an API itself with certain tools that exist out there is almost trivial. It's not completely trivial, but almost. And the reason for it is that these tools hide a lot of complexity and do things in an automated manner. Like for example, you might, okay, let's see if I can find a good example. Let's C sharp API. It's let's look on GitHub. GitHub. Okay, so let's look at one of the controllers. Okay, so the reason why I say that is because when you look at this code in C sharp, right, you can see that they add some special decorators to the endpoints of an API, and behind the scenes, the tooling will take care of generating a Swagger UI so that we can inspect the different endpoints, the payloads, and the responses. Let's see an example of a Swagger UI. Guys, so stop me if you have any questions. I'm making the assumption that everyone knows more or less what an API is. So if you have any questions or if anything is confusing, stop me so I can explain.
Yeah, maybe just kind of given like definition of like maybe what an API is, for maybe those who may not know.
Okay, I mean an API is how can I say it? Okay, so let's take the example of a website, right? When you navigate to your browser makes some HTTP request to a server, and then that server responds with HTML, right? So nowadays, what we refer to as HTML is that, as APIs, is that instead of calling a server and receiving HTML, we want to receive data instead, and usually structured data. So structured data like XML or JSON. XML used to be the standard that most people used some years ago, and then it got complicated, and everyone pretty much switched to JSON, right? So today, a simple definition would be an HTTP request that hits a server, and then the server responds with JSON. So the implementation of such a server that returns JSON when a specific path is invoked is pretty much an API, like to make it simple. So like you can see over here, so if we imagine that this is the address, we imagine that this is the server address, and then we call this path. invoking this path, will lead the server to do some sort of processing on the server side and then return a response, right? So the Swagger UI that I was referring to is this one. So you can see what type of parameters are required for the server to process the request. And then this is an example of what the server response may look like, right? And also, one thing that's directly related to APIs is the HTTP verbs. So we have several, but the most commonly used, you can see them here, like post would be to create some new data on the server. Let's say someone registers to a website via an API, right? Or someone wants to, I don't know, add a new item to an inventory through an API, or someone wants to place an order, just like this one. That will create a resource that will send the data to be processed by the server and saved into some database. And then the response will be the confirmation that the operation was successful, right? Put is meant to replace an entity. So let's say someone mentioned that added a new T-shirt to the T-shirt inventory and added a new T-shirt that says, okay, this is a green T-shirt, size XL. And then the person later on noticed that there was a mistake and needs to replace it via an API call. So put will be the one to use to replace it, let's say, with a red shirt, right? But if instead we do not want to replace the entity, but we just want to make a small modification, there is another verb which is called patch. It's not here, but there is a patch verb to do just that. And then get, like the name implies, is meant to retrieve something from the server, and delete is also self-explanatory, right? So that's UI that I just showed. A lot of the modern tooling, just like we see here in C# and many others, like even on Python with Fast API, is the same. The mere fact of defining some entities and endpoints automatically generates a Swagger UI, and this way of defining the I mean, in a way, the contract of how to interact with the API server as well as the UI, it's convenient for small teams, like maybe a couple of people, right? But in a larger team, it's not the recommended approach. The reason for it is that it's very easy to change code, right? So every time someone changes the code for whatever reason, the people consuming the API have to somehow be aware of it, right? So that can lead to the teams that collaborate to waste a lot of time in communications and confusions and all that. So for that reason, an approach that directly generates the OpenAPI spec and all that, it's not recommended. So what we really want is for the teams to come up with an agreement, like a contract, right? So instead of writing code first, and have all of the contract generated, we do the inverse. We want to start with the contract that everyone agrees on, and then each team can move separately and build the API server or build the API client. Like, does it make sense?
Yes.
Okay, so let's proceed. So the contract or the spec that I keep referring to is based on JSON schemas. So JSON schemas is basically a way to leverage JSON to define a contract of how a client and a server will exchange information, right? So some things that will be specified would be, for example, like what an input to the server call for the server call will look like. Like you can see here, we have a pet that has a name, it has a status, category, and so on, right? And we also have a response. So pretty much that contract says that, let's say if we post a user, meaning if we send a user with these fields to the server as a post request, then the server will respond to us with a response that has this shape. And maybe the message will say that it was the user was successfully created in the database, or if there is any problem, it will mention in the message that, oh, there was an error trying to create that user because, I don't know, maybe that user already exists, right? So JSON is the format to do that. And you can actually see in the Swagger UI, there is usually a link to that JSON. And this is what the contract actually looks like, right? So it has all of the entities, the code paths, you know, to make the post request, the get request, the put request, and so on. You know, the HTTP status codes and all that stuff, right? The contract can specify more than what I just mentioned, with things like that, with things that have to do with security, routing, and all that stuff. But to keep it simple, just focus on the data exchange between the client and the server. Okay. So JSON schema is what's used to set up the contract. But I have a question for the audience. Would you like to have to write something like this by hand as part of your work?
It's definitely not fun writing it.
Hopefully not.
What people do, but it's not nice.
Exactly. It's very error prone, it's very verbose, and it's not fun. So for that reason, like some I think let me see if I'm not making a mistake. If I'm not mistaken, there is a guy that used to work at Google, and based on his experience there of how they define contracts, you know, he came up with this tool, which is called Q. So Q is based on, actually, I forgot something. I forgot to share you guys the link so you can follow along. I'm pasting the link in the chat. I have some reference links as well. Okay. So let me go back. Okay. So Q is made to streamline the creation of contracts. You know, so some of the contracts that are supported are, for example, JSON schema, like I just mentioned. It also has support for protocol buffers, you know, and it also knows about the OpenAPI specification, which is OpenAPI itself is I don't know how to say, is literally JSON schema, but with some conventions added into it, right? And then the format of those protocols can be JSON or YAML. YAML being a superset of JSON. Okay, so to give you an idea of why, an example of why this is very neat, is that like I remember some years ago, I worked on a contract with telcos, and I'm pretty sure everyone knows that you could have let's say you could have a subscription with Sprint, right? And then tomorrow you notice that, hey, maybe AT&T has a better deal, and then you get to just take your phone number with you to AT&T, right? Behind the scenes, the telco providers have to have a contract or like a contract or an agreement on how to make it easy for customers to move from one provider to the other. And the way that they do that, I'll show you. Let me see if I remember. OpenAPI and GitHub. So the way that they do that is that they all came up with some specifications having to do with customer data, with customer data in general, and they leverage Swagger or OpenAPI, right? So this is an example of them coming together like worldwide and agree on some contracts and specifications, right? Which is also versioned, and then they all go ahead and implement the APIs based on those specifications, so that the way that Verizon will store the customer data for cell phone service will be compatible with how AT&T does it, and so on and so on. So that's moving the customer data from one provider to the other is really smooth. That's an example.
So that I understand, I think you said, I just want to make sure I understand. So are you saying that all the telcos, so they are expecting this kind of JSON if, for example, I'm moving from T-Mobile to AT&T, and then they have to send my information to them, they are expecting that JSON, right, from where I'm coming from to where I'm going. And like you said, they basically implemented ways, okay, when they receive that payload, they're able to kind of like insert that right away into the database, no problem. That's what you're saying?
Yes.
Okay.
Yes. So you know how like at work, right? You might have a project that's supposed to be shared throughout the company with different departments and so on and so on. You see, there's a lot of communication and a lot of overhead, right? So the fact that they came up with this organization that generates those contracts, it helps to do that at scale, from one large company to the other.
Mm-hmm.
So, got it. Yeah. Okay. So I shared the links in the chat. So let's go back to, let me see. Okay. So one last remark is that we saw the concept of the format of a specification or a contract, right? We are familiar with this idea of contract first, and we saw the Swagger UI, It helps us browse the different API endpoints and gain some knowledge on the inputs and outputs. And then we also know that we definitely do not want to write this by hand, right? And from that point, I started mentioning about Q. Let me see, what is it? Yes, so I mentioned about Q. So, so the cool thing about Q is that it's plain text. It's using plain text, and it's a very simplified way of writing JSON or of producing either JSON or YAML, right? And let me see. So I'll show you I'll show you what it looks like. So let's switch to the presentation that I wrote. So we saw all of those concepts, right? But there's one additional concept that's very important. When the contract is defined, right? Let's say we want to create a user. The user has a name, an age, a height, weight, and so on. How does the server know that the data being sent to it is valid? Because it's one thing to specify the contract, but it's a completely different thing to enforce the contract, right? Like we drive all the time. They say, okay, don't go through the intersection on right, but people do it all the time. So there needs to be some dynamic process, like maybe like the police, monitoring the intersection to enforce the law if someone goes through the intersection at the red light, right?
Yep.
Yeah. Okay.
Like speed trap or something like that. Yeah.
Yes. So that means that we need to be able to enforce the contracts at runtime by doing some validations, right? And coming back to Q, the nice thing about Q is that not only it lets us generate those, easily generate these specifications and contracts, we can also leverage it to validate the inputs and outputs at runtime, right? And so today, in the demos, I've made the demos with, I've built the APIs with Go, and the main reason for it is that Q itself is written in Go, so it's very compatible, right? And it's easy to integrate. But the same concept that I'm going to show, also it's possible to do it in any other languages. It doesn't matter if it's Node.js, Python, it doesn't matter. Similar approaches are possible. Okay. So I have a section here to walk you through the installation of the tools that I'm going to use. So essentially, I'm gonna use Go and Q for the most part, right? And here I have Go env. This one allows to install the version of Go that we want to use. So I'm gonna use Go 123, and then once we have the Go CLI installed, then we can directly install Q as a library, right? And then we can check the Q version. So I'll go to my terminal. So Go version just to check. Okay, so I'm using 123 and then Q version. Okay. So you can see that this version of Q was built with Go 123.0. Yeah.
Can you increase the size just a little bit more, please?
Sure.
Yeah, thank you.
Is it better?
Yeah, I think it's better, yeah.
Okay. Okay, so I was saying that I'm using Go 123, and then Q was built with Go 123.0. And on my machine, I'm using 123.3. Okay, so let's move on. So another advantage of Go is that the standard library is, is packed full of like functionality. So you should be able to replicate these examples like quite easily by just having Go installed on your machine. So, so the first thing, the first package from that standard library that we're going to employ is the HTTP package, right? So the HTTP package contains all the functionality to make API calls, as well as to generate HTTP servers. So here you see an example of how easy it is to make a GET request to some server and get a response, right? So it's literally importing the net HTTP and then HTTP.get and then the URL, right? And then if for some reason it fails, the error will not be null, and then we can print the error. And then this is how we get the body. In this case, the body might be like some bytes, a stream of bytes, so that we can read them all. And yeah, any question on that? Okay, let's move on. So the same way that we can do a GET, we can also do a POST. Yeah, so same thing. We can specify the URL, the headers, and then the payload. So in this case, it's a JSON payload with key value, right? And then we print the result. Okay, so this example here is how to set up a Hello World server. Okay, so again, the same package HTTP, we create a handler. W stands for writer, so it writes the response to the HTTP connection, so that response makes it back to the client. And then the R is for request. This is the request coming from the client, right? So we can read things from the request, do some processing, and then write the response using the W. Okay. And then here we just spawn the server to run on port 8080. Oh yeah, and also this is the mapping, right? So /hello will point to this endpoint. Okay. Okay, so let's move on. Okay, so let's see. Okay, I'm also using this small library called JSON. This is a helper library to easily process JSON responses, right? So that we can extract some values from the JSON object. So, for example, if we have a nested JSON object, this is how we can traverse it. So this will be the JSON, and then we can traverse it to access nested fields, by separating them by dots. Okay, so let's see it in action. Let me see if I can decrease a little bit so I can see. Okay, so in this case, it's a simple. I'm defining the URL. I want to interact with OpenAI, right? So I'll specify the URL for OpenAI. I'll grab the OpenAI key from the from the environment, and then I want to process this image. So if you want to see what the image looks like, it's checked into the repo. I think visual. Yeah, so this is the image. That's the image that I generated for the for today's event, right? So now that you saw what it looks like, basically what I want to do, I want to extract some information out of this image using the OpenAI API, right? So here, the first thing that I do is that I have the image path. So the image is located into the assets folder, like on the left. And then I'm just printing a message that I want to process it. And then we know that the GPT-4o is multimodal, right? It doesn't just do text, it does images as well. But the way that it processes images is it's a bit unusual for people who are not used to this way of processing data. But essentially, when we have the image on disk, we can grab the path. We can read the bytes of that image on disk, okay? And then we can encode it to base 64, right? And the base 64, again, it's you can see the libraries that I'm importing here. All of them come directly from the Go standard library, with the exception of that JSON one that will help us pass the JSON response from OpenAI. Okay, so once we have the base 64 encoding of the bytes of that image, then we can create a payload, a JSON payload. So it's a nested map. You can recognize the structure of that map if you've played with OpenAI in the past. So I'm specifying the model GPT-4o. I want to use a maximum of 4,096 tokens, and then I pass it a prompt. So the prompt is specified here. The information I want to retrieve from the image is this: a description of the scenery that's inside the image. Okay, and this is the interesting part. To send the base 64 to OpenAI, it's basically a very long string, which is prefixed by data image and then /webp base 64. The reason why it's webp is simply because my file extension for the image is webp. It could have been JPEG or PNG, it doesn't matter. You know, and then we semicolon, we say that it's in base 64, and then we add the base 64 encoded bytes.
I have a question.
Yes, go ahead.
So does the extension, did you need to provide the extension to OpenAI to be able to pretty much recompile the image? Is that why?
So okay, how can I say it? So the different image formats are not encoded the same. You know, WebP is encoded. The way that WebP images are encoded are different than how PNGs are encoded, are different than how JPEGs are encoded. So since we are providing the raw bytes, we want to help OpenAI know how to decode it. You know, so if we don't specify it and it picks the wrong decoder, it's not gonna be able to, to see what's inside the image. Yeah, so that's the reason why we specify this. Same thing, when you build a website and you serve images, right? The image will have a MIME type. It will say it's a JPEG image so that the browser knows what to do with it. Or if it's a PNG, the MIME type will be there. Let me see if I can find an example. Let's go to Pinterest. I don't know if they're gonna let us. Okay. So if we inspect this, what's this one? I'll go to network, I'll reload, and then I'll filter by images. Okay, if we look at the headers, yeah, so you see, this is the MIME type for the image. So this is a JPEG, right? So this is done just like it's done in the browser and many other systems. The system that receives the bytes of the image has to know how to process it, how to decode it, right? So in this, and to make it easy in this case for the website, we have the extension JPEG. So automatically the server that serves that website will see this and set the header to image JPEG. So yeah, so it's the same thing that's happening here. I think even for the Ubuntu sites, Ubuntu. So if we go to this one, I'll reload this. Okay, so this is the image. So we see WebP, and then we can see it here, image WebP, same thing. Okay. Any more questions on that? Okay, so let's continue. So pretty much this will be a very long string because it has this part which prefixes some bytes. So the bytes can be very long potentially, depending on the size of the image. Okay, and so same thing, if for some reason there's an error into the creation of that JSON, it's gonna print. And then finally, it makes the post request, right? So we use the URL that was specified above, and then we get the bytes of that, of that JSON payload, and then we post. And in case of failure, we print. And then this is important. We have to set the authentication header. And this authentication is of type, it's a bearer token. So it has to be exactly like this. So bearer space, and then the OpenAPI, the OpenAI key. And then since we're sending JSON, we have to tell the server that we're sending a JSON payload, right? So it's going to run, and then it's going to return a response. Okay, so I can delete this and run it again so you can see. Actually, okay, and then let me uncomment this one. Okay, so I can execute this. What did I do? I think I made an error somewhere. Okay, that's fine. I have the same thing in my terminal. I'll run it from here. Okay, so I have the equivalent in my terminal. So it's this method, so it's the same thing I just showed. And then this is going to print. So I'm actually gonna uncomment this part so that we see the whole JSON response. And then we're gonna see also how that JSON library helps us, extract the field that we want, which is the content. So let's run it. Let's see. Okay, so it's simple. I'm not gonna compile it. We can compile go to a binary, but I'm not doing that here. So go run. Create. This is a CLI, so I'm passing the command, which is to process the image, and then we have the path. Actually, I can show you. Okay, so this is the CLI, right? So the command is imgi to process the image, and then also pass a prompt. So if I run this, okay, so you can see extracting info from blah, blah, blah. Okay, and then this is the full response from coming back from OpenAI. Oh, I think my computer is slowing down. Let me see if I can close some windows. 1 second. So I think the streaming is slowing down the machine. Okay. Okay, so this is the full response. So sorry, guys. I think I have to shut down some stuff. Let me kill this one. Okay, so I'm back to green. Okay. So this is the full response. You can see some metadata for OpenAI from OpenAI, the model that was actually used. But then we can see that the response is buried inside here. So we have choices, which is a list. So we want to get the first element since it's a list of 1. And then once we have the first elements, we want to grab the message and then the content. So that's exactly what I was showing you here. So choices, first element is 0, message, content, right? And then below it, we actually have the response. So if you look at the image again, this one, it says that it depicts a vibrant, futuristic workspace with an imaginative blend of technology and cultural art, blah, 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 blah. So, any question on that?
Could you do a side-by-side view of the API server and the API calls that you're making? And if you can also add like some prints or system logs so we can actually see it in action. Because right now it seems like it's the same thing that is doing everything.
Yeah, so right now I was just demonstrating the HTTP client. The server itself is located with OpenAI or Microsoft. It's not running locally.
But you built this client, right?
Right.
You built an API, and then so you first ran the API, and then you made the call. So from running the API to making the call, it looks like it's one single thing that you're doing. Like it's not.
No, I'm not running the API. OpenAI is running the API, and I'm just calling it.
So you're calling.
So OpenAI.
No, I understand that. So the Go app that you built, right?
Right.
So where did you run it? Where did you start the Go app before you can make the calls to it?
No, it runs once. It's not a server. So you see the CLI.go is this one.
Mm-hmm.
This file, right? And like I was showing earlier, so if I run it without any parameters, you can see that it's just a CLI.
Okay.
With different commands. So the command I'm using is imgi, which is this one. And if I do help imgi, you can see that imgi takes two parameters. The first one is the image path, which is this one.
Mm-hmm.
And then the second parameter is the prompt, which is this one.
I'm still confused. I'm trying to understand the whole Go app that you built and how you actually, from the time you're running it or compiling it to the time you're making calls to it.
I think, from my understanding, maybe let me not speak for you, Ben, but I think what the app just does is send an image to OpenAI for OpenAI to describe it. Is that correct?
Exactly.
Yeah. So in order to send the image, you can't send a PNG or JPEG. You need to do that base 64 conversion to text, and
Right.
then just do like a HTTP request, just a basic HTTP request to OpenAI. So I don't think Ben has created
So
an
he
API
hasn't.
yet.
Yeah, Ben hasn't created an API. Okay. I'm
Yeah,
sorry.
yeah.
I thought you built an API for using Go, and then you're making calls to it.
Not yet. No. I don't
No,
think we're there yet.
yeah. I'm just at the client part, just to
Got
show
it.
how we can invoke an API.
Okay. All right. Thank you. Sorry about that.
No problem.
Okay. Any other questions? Okay, so let's proceed. So we saw that in action. Oh, let me go back to the README. So we saw that we how to an example. This was an example of how to consume an API, right? So actually, JSON schema. So the open. Trying to see. Do they have it somewhere? Oh, I think I put the wrong thing. Open API spec. Okay. So just like we saw the Swagger earlier, OpenAPI also publishes the contract that they have, right? And I think the one I was completions, the one I was invoking, I think is chat completion. Yeah, so it's this endpoint that I was invoking. Right? So it's this endpoint that I was invoking, and yeah. So basically, following the contract that they have, like the contract that they have and make available to the public, helps me know as a client how to invoke it. There's no need for any special libraries, right? So I just follow the spec, created the payload as they expect, send it to them, and then they respond just the way that they specify the response will be, right? So we just saw that response, right? So we can, me as a client and them as a service provider or with an API, we agree on that contract, and that's how we can exchange information. Okay, so moving on. So let's take a look at Q. Okay, so Q, this is what the syntax look like. I mean, part of the syntax. So Who can tell me what this is by just looking at it?
Person object with attributes like name, age, email, and then after that you have the data types. And I think after the data type you have constraints on like what the style of the email should be. So maybe I'm guessing here.
Yeah, that's correct. So the name is a string. The age should be a number. I don't know. Okay, up to 120. Maybe I should have put 300. I'm too pessimistic here. And then the email. This is like a regular expression to make the email, right? So essentially, it's very terse. There's no extra curly braces or double quotes and none of that. It's basically what we need. Like in the noisy, out of the noisy JSON syntax for defining contracts, we get to specify the actual signal, and the rest Q can take care of it for us. Okay. So let's see the integration with Go. So the nice thing is, like I mentioned earlier, Q itself is written in Go, so we can reuse it as a library. And given that we have a Go struct, which is equivalent to a data class, equivalent to a class with data fields, and so on and so on, right? That's the equivalent for Go. So we have name, age, and email, okay? Plus some metadata. The way that we can validate this at runtime using Q is this way. We literally copy and paste that previous person definition, okay? And from a Q context that we create, we can compile a string and obtain a validator, and then that validator can validate the data. I think I'm missing data somewhere. I think it's like that, if I'm not mistaken. Anyway, I'll check back my notes. I have some code written, we can see it more clearly, right? So there are some other examples of like Q. If I'm not mistaken, I think Q is also used in the source code of Kubernetes, if I'm not mistaken. Okay. So those are some commands that and ID extensions to support Q. And yeah, some reference links and so on and so on. Okay, so this talks about the integration with Go. So let's look at a simple demo. So let me tangle these ones. So in here, I'm defining a simple user that has an ID and a name. The name should be a string, like with the alphabet letters, lowercase, uppercase, and that's it. So it means that it should not contain any numbers or anything like that. Okay, so let's see the demos. I think this is the one. So now we're defining a simple API. Okay. So like I showed you earlier, we have the user, we copied and pasted the Q definition for user with the constraint, we generate the user schema that we can use to validate. Okay.
Wait. Can you talk about that more? So you generate the user schema and use to validate. Do you mind going over that again?
Sure. So you can see I'm importing Q and the queue context as a library.
Mhm.
I define the Go a user, a Go representation of a user. Okay, and then the schema itself is a string, which is the copy and pasted version of the queue definition we saw earlier for the user, together with the restrictions. And then we create a context, a queue context. With the context, we can compile that definition into a user schema.
Mm.
Okay, and then we have a helper method to validate users. So users is the Go representation of the user.
Mm.
Okay, so the context lets us convert that user into some format that Q understands. And then from the schema that we derive from the Q string definition, we can say that we want to validate the user, which is this path in the schema. We want to validate the user with that path in the schema, which is the Q definition here. And then if it fails, it's going to return an error. So the error will not be null. Yeah. And then in here, this is the endpoint definition. So we saw the request and the response, right? So the reader, the request and the writer. So the user makes an HTTP request, the client makes an HTTP request, which will be handled from this endpoint. Okay, so we read the JSON from the request body, and turn it into a Go user struct. Okay, so once we can successfully decode that user, the value of that user will be inside this variable that we can use to call the validation. So this is that runtime validation that I mentioned earlier. Okay, and if it fails for some reason, it means that the error is not null. And if it's not null, then we write the log to the console, and then we return an error to the client. But if it's null, then it means that it's successful, and then we just return that user to the client. Okay, and then the handler itself, this is how we specify it in the recent versions of Go. In the recent versions of Go, when we specify the path, we can prefix it with the HTTP verbs that should be used. So in that case, it's a post. Sorry. So it's a post request to /user. So let's see it in action. So we'll go run. So demos, I think this is demo number 2. Okay. So the server is running. And we expand this one. Okay. Oh, wait. Actually, let me copy my curl comment.
Sorry, maybe I missed something here. When you say the server is running, is there like a special server or?
Yeah, it's the one I just showed you. This is the server.
Oh, okay.
Yeah, remember I was showing you the HTTP package earlier from Go.
Oh, okay, got it.
Yeah, so this one lets us define a server that way.
Got it.
So see, HTTP listen and serve on port 8080. Yeah. So So that server is running right now in this tab. And I'm just going to grab my current request. Where did I put it? Oh, okay. Oh, actually, it's here. And so actually, we can run it from here and see the execution. Okay. So let me do it from the terminal so it's easier to see. So here I'm doing the happy path, right? So I'm sending a user. This is his name is John Doe. His ID is 1, right? So this is the expected. The shape of that user, fulfills the contract on the client part, right? It does what's expected of the client. So if I run it, I get the entity back, right? Yes.
I get a black screen. I'm not sure whether it's just me. Oh, okay, I can see now. Sorry.
You can see?
Yeah.
So I was just running the happy path with some valid data for the user. So ID, it should be a number, and the name should be a string. So there's no error here, right? And then if we look at the, oh, okay, that's my previous one. Hold on. Let me clear this. Okay, so it's running. So if I run this, we don't see any errors here. But then, let's say I want to create a user whose name is 1234, right? Then I'll run it. This time, the client receives an error message saying that the name has an invalid value of 1234. And what it should actually be is a series of characters from the alphabet, uppercase or lowercase. And then if we look at the server logs, we can see that the server logged that the payload it received was invalid with the same error message. Does it make sense?
Yep. So in essence, in the code, you probably just, when you're getting that payload, you're probably just doing like a print or something like that. But in other cases, it could be like a putting it in a database or something like that, correct?
Yes.
Okay.
Yes. So after the validation, pretty much here we could do like insert into database or something.
Yeah. Yeah.
Or register user, like anything. Okay, so let's continue. So that's what we saw, right? So passing some valid data, is the happy path test, and we get the payload back. But in the failure, like when we fail the validation by passing some unexpected value, then we get this. Okay. So that's cool and all, but we are still looking to we still want to reach this level, meaning that we have an open API spec in JSON format, and we have a Swagger UI to go along with it. So how do we do that? So since we specify the queue definition, see, this is the same user definition as a standalone file, right? So user.queue. Let me see. Right, I'll keep it on the right side. So since we have this, how do we create the OpenAPI spec out of it? So I can copy this one, this command, and so if you remember my CLI from earlier, earlier we ran the information extraction from the image, right? So this time around, I want to invoke the Y2J. So Y2J, what it does is it takes in, actually I have to run it after. But that Y2J basically converts YAML to JSON. But the YAML that we want to convert is basically a conversion from the, let me see, where am I? I think I skipped a step here. Okay, so the YAML that we want to convert is this one. So let me copy it to the, we remove the previous one. Okay, so the YAML that we want to convert is this one, basic schema.yaml. So if you see what's happening here, we're using the Q CLI to take in as input the user.q, which is the one on the right, and it's going to turn this into the OpenAPI specification format for us. Okay, so we're gonna go from a thirst definition to OpenAPI, right? So this is how the CLI call is structured. So Q, we want to define the OpenAPI format in YAML format, the OpenAPI specification in YAML format. So it takes in the Q file as an input, and then the -o is the output, and we want to output the result into a file called basic schema.yaml. So if I run this, okay, it already ran. Actually, let me use that. And then this is what it generated. Okay, so you can recognize the syntax from OpenAPI, right? So we have the OpenAPI key with the version, which is 3, the version 3 series, and then the title. The title can be changed. It doesn't have to be generated by Q. And we can also specify the version, right? The only thing that's missing, before I go there, we also have the components part that contains the schema. And then you can see that we have the user, and the user has properties ID of type string and name of type string with the constraint, the same constraint that we saw in the user, in the Q user definition, right? That does it make sense?
Mhm.
Okay, so if it makes sense, then I have a question for you. What's missing into that generated OpenAPI specification? The answer is in the output here, if you read it.
I mean, I can see the constraint on the name. I don't see the constraint maybe on the ID. The email, I don't also see the email. The other one had email, right?
No, it's just ID and name.
Oh, okay. No.
Yeah, I give you a clue. Out of this, we want to create a server. an API server. So with that knowledge, what's missing that you can see? Like if this is the contract for the server, right? As a client, how are you supposed to invoke it?
It's the path, right? Should be the path.
Exactly.
Yeah.
Exactly. So Q does not at the moment support the generation of the path. I've tried doing it manually in the past, but it was a nightmare to do it until I was so frustrated. I kept reading the documentation and then it was written right there. They don't support the paths. I don't know why, but they just don't. Right? So meaning that we need to do this part manually. Maybe in the future, they will add support for defining the paths directly in the same Q file, but as far as I know, from now, they don't. Okay. So this part, we need to address it by hand. So how do we address it by hand? So this is the same output I just showed you in the terminal. So to address it by hand, it's very simple. So this is a YAML format, right? So notice the path in here. Let's say we want the path to be /users. And we want the /users endpoint to be a post endpoint. We only support the HTTP post, the HTTP verb post, right? And then we want some sort of description, let's say like create user. And the request body should be, is required, okay? And it should be in the JSON format. You know, the payload that we send to the server should be in JSON format, like so it should say that in the headers. And then the shape of that user in the payload is our same user with ID and name, right? And then this ref here, it's like a link. So this ref is pointing to this location here. You can actually tell component schemas user, component schemas user. And then we have the same type definition that we saw in the console. Okay. So that's how we can get a full specification from Q. So we can go from something that small to something with way more details. And the only work that we have to do here is to specify the paths. Any question on that? No? Okay. So let's proceed. So we just saw this. That's the server we ran earlier. And we also saw the happy path scenario and the, what is it called? And then the failure scenario. And let's see if we try this. And then after we patch after we add the paths, the specification looks like this. Okay. So now we want to turn this into JSON. So how do we do that? So same thing, using Go and the YAML library, a YAML library for Go that I installed. We can literally convert that that YAML file into JSON. So let's come here. So from the help, we saw that there's Y2J, so it stands for YAML to JSON. And then from the help menu of the Y2J commands, we can see that we need to specify an input YAML and an output. Okay. So let me remove the previous one, the 3. So I'm removing this one, then I paste. Okay, so this one is going to do the conversion. And then we get the OpenAPI JSON. So we can navigate there. And then here it is. Okay. It's a bit out of order but you can recognize the section. So we have OpenAPI, we have title and version, we have the paths. We have the link to the components, and we can see the user with the constraints, and then the required fields out of that user, which are ID and name. Okay, any question on that? Okay, so let's proceed. Let's go to. So here I have an updated version of the server. So I took the same server that we tried earlier with the validation, the endpoint, and all that. And this time around, I want to serve that OpenAPI JSON. I want the server to basically expose that OpenAPI JSON. So actually, let me run it so we can see. So we'll run. So let me go to demos. So we'll run demo 3. Okay, so it's up and running. And okay, so I'm exposing the OpenAPI JSON, and then I'm also exposing the docs. The docs will be the Swagger UI. And the Swagger UI is basically an HTML file, which is here. I just pasted the HTML as a string in the code instead of having a separate template, right? And then this HTML will load the JavaScript and the CSS for the Swagger UI. And then you can see here on this line that JavaScript, when it executes, it's going to load the OpenAPI JSON that is being exposed by the server. And that OpenAPI JSON is the one we just created on the right. Okay. And like I showed you for this example online, you can see that this one is what? Pet store, Swagger, IO, V2, Swagger. This is where the JSON is located. Okay, so let me see, it's run on port 8080. And let me open a new tab. Oh, 404 not found. Do you guys know why it says 404 not found? Because we haven't defined anything at that path. Okay, what we really want is located at this with this path, which is the OpenAPI JSON. So we can see the JSON itself. And the Swagger UI is at /docs. And then we can see it. And then you can see that when this page loads, it also took care of loading the OpenAPI JSON. Then what do we see? We see the same Swagger UI. right? And obviously we can interact with it. So let's put some ID, blah, blah, blah. I'll put some name. Then I can click the button to execute it. And then we can see the response is successful, right? And then let's say number 5. And then if I run this time I get an error because we should only have alphabet letters, uppercase or lowercase. Any question on that? Is there any question? Because you are the one curious about APIs. Like no one? Hey guys, can you hear me, or I don't know if I'm disconnected?
Yes, sir.
Okay. Because it's very quiet, so just checking. Okay, so now you know how the sausage is made. What we just saw is how to define the contract first, and like using queue so that it's not as tedious to write. So from the queue definition of the different entities, we can generate a YAML document in which we can, like the YAML is also less tedious to write than the JSON. So from that YAML document, we add the parts that queue doesn't do for us, notably the paths. Once we have the paths defined, we can convert that YAML back into JSON so that it can directly be consumed by the Swagger UI. And the Swagger UI itself is open source. So we can just grab the assets, like the JavaScript and the CSS, with a little bit of HTML, and then we are in business. Okay, so you know how the sausage is made here. Okay, so I actually have a 4th part, but I was hoping to have completed this like much faster. But basically, what I wanted to do here is revisit what we just saw into something more concrete. I'm actually going to show you the. I'll show you the UI for it. Let me see the modes. Okay, so I have a small UI. It's built in Next.js, and all it does is to is it loading? Okay, so all it does is to reproduce the scenario that we did earlier, right? So the idea here is that we can upload an image. So let's pick this one. We can upload an image, and then when we call process, behind the scenes, it will take this image, convert it to bytes. Actually, it will grab the bytes out of that image, encode it into base 64, and then make an API call to a server that we want to implement. Just implement it the way that we just saw, like step by step, right? And then that server will will receive the image bytes and then forward it to OpenAPI together with the prompt. And then OpenAPI will extract the information that was requested via the prompt, send it back to the API server we build, and then the server will respond to this UI by just printing the information that we retrieved from the uploaded image. Okay. Any question on that? Okay. So I'll walk you through the like the structures, and then let me see. Actually, here it is. So I won't bother you with the details of the UI itself, but this is the part that does the work, you know. So when we post that form, by clicking process photo, you know, we are going to receive it as this object form data. And the form data has a field called photo, which is the actual bytes of the photo we uploaded. And then to encode it into base64, we create a buffer and we grab the, we grab the bytes from the image and then encode it into base64. Like this is just using the built-in Node.js standard library. Okay, and then we make an API call to the process photo endpoints as a post request, kind of like what we saw earlier. And then in here, we just we just pass the base64 encoded image to the photo field and then post it to the server for processing, right? And then here we have to do some additional work to pass the response and get the information that was extracted from the image, and then it will be passed back to the UI for display. Okay, and okay, so this is a definition that I started writing. I haven't completed this demo, but I'm just showing you the steps. So in this case, we have the image upload entity. And also, same thing as earlier, it takes an ID, which can be like some random characters, alphanumerical characters. It takes an image title, so we can have a name for the image. Just like in here, we have from Go APIs to Frontends at WebP. And the image itself is also a string, but this time it's a very large string, right? You know, and this is where we specify those are the options for the image format that this contract supports. So actually, I'm missing one, like WebP. Okay. So basically, when we have the bytes, like there is a direct correlation between the length of the string, because those encoded bytes are literally strings. So there's a direct correlation between the length of that string and the size of the image, right? So this constraint will ensure that we do not process images that are larger than 10 megs in size. Okay. So same thing as earlier, we can generate the YAML. Actually, let me check. I think this one is already should already be here. Contracts. Wait, wrong folder. Okay, so this is the queue definition. Actually, so it's hard to see. So this is the queue definition. It's already on disk. Okay, so out of that, I can create the YAML file. Oh, wait, how to delete the. I think I have a typo somewhere. Okay, then that's fine. I'm not gonna bother you with this. So essentially, we are redoing the same steps as earlier. So from the contract, we generate the YAML, and then we have to add the paths, and after that, we can generate the OpenAPI JSON. And then using a similar structure as what we did earlier, we can add the code to load that OpenAPI JSON from disk. We can define the validators to make sure that the image doesn't go beyond 10 megs. And then we can also add the sample code I showed earlier that collects the bytes from the image in order to submit it to OpenAI together with some prompt, right? And then as a result, we're gonna get that big JSON from OpenAI, and then we can grab the content and then send it back to the front end like this. So I think I can leave this as an exercise since we are pretty much out of time. So that's what I'll show you today.
Is that for part 2 that is coming, or just?
Well, we can do a part 2, definitely. Definitely.
Just kidding. All right.
We can do a part 2 with something because in part 2 we can explore things like streaming APIs. Because at times the payloads might be too big to send all at once. So there are some techniques that exist to stream the API back to the client. So actually, the different use cases for AI, right? Those are perfect for to leverage those techniques because, okay, in the case of AI, it's not so much that the payloads are that big. It's more like the model providers, are quite slow to respond. Like especially if you pick a model which is on the larger side, it requires much more resources, like in terms of GPU, memory, and all. So the responses don't come fast. And during that processing time, we do not want the client to just like wait, not knowing what's happening, right? So as soon as the processing starts on the side of the model providers, they can start streaming the responses, right? So if they are streaming the responses from our backend, we don't want to buffer those responses. We want to pass them along to the client right away, right? So in this case, OpenAI will be streaming the response back, our Go backend will also stream that same response, back to the UI, so that we can start seeing the text printing word by word, describing the image, right? So in another part, we can explore these scenarios and build something more interesting. So,
do you have like resources in terms of? I know you talked about a queue and Swag. Was it Swagger? Yeah, Swagger. Those are kind of tools to handle, to deal with APIs and stuff. Do you have other tools as well, or other resources? If one wants to get more into this.
I mean,
or is that pretty much it?
I mean, that's the okay. What I just showed, that's my preference today, especially when we do the contract first. But if the contract first is, I mean, you don't want to bother with that, then you can pick any of the existing tools. Like there's one very popular one called Fast API. Let me see. Okay. Like Fast API, like this. Let's see if we have learned. Start getting started somewhere. I'm not seeing the steps here. Okay. I'm not seeing it right now, but with Fast API will be like a good candidate. This one doesn't do contract first. You literally, okay, here it is. You literally define your entities.
Oh, Pydantic.
And then right away, yeah, as Pydantic, as a Pydantic model, or as Pydantic models, and then right away from the Pydantic definition and the path, you get a Swagger UI and then OpenAPI spec. Right? So this is like very direct. Right? So the setup I showed you, at least in places where I've worked before, some of it is done manually, including writing that giant JSON specification.
Yeah, that's not good.
And that really sucked. Like we spent like weeks and weeks like tweaking that JSON by hand. Because you do it a certain way, and another team there complains that why is this? Why is it not an array? Why is yeah. So yeah.
Makes sense. Okay. Thank you.
Yeah. Any other questions, comments? Yeah, go ahead.
Not really a question, but more of a comment and something for next. So before I jump into this call, I was under the impression that you were going to build a Go API from scratch, like from start all the way to finish, and then connect it to the OpenAI. I was like doing stuff on the side too, so I really don't know if I missed it or not. But can you actually, for the next presentation or whatever, when you have a chance, can you actually do that? Because one thing that I like about Go versus Fast API is from the libraries that you were importing, they were all coming from Go. And Fast API, you have a lot of stuff like Pydantic, and then you have like Jose and all that stuff. And sometimes they're not compatible. You know what I mean?
Yep, exactly.
Yep. So if you can just show us like how to build an API from scratch using Go and maybe put it on the server as well, that would be really great.
Okay, so that will be part 2 then. The where I stopped, I'm gonna continue that. So let me see. Yeah, so that's where I stopped. You see demo 4, but basically I was hoping to finish the first 3 parts much faster so that we could just build it live, but I ran out of time. That's why I of like built the UI ahead of time, thinking that I will save enough time to get to this part, but yeah. So definitely I can do part 2 of this.
Wonderful.
From that contract and then build up to the integration with the UI. Yeah. This my goal is basically to remove the mystery around like things like APIs and stuff like that. It's simple, but like the information is kind of weird out there, because most tutorials you will see or books and all, they talk about the other scenario where it's coding first, not contract first. So yep. Any other comments, questions, or anything? The floor is open. Anything you want to mention?
Using both Fast API, Go, and other like Node.js and all that stuff. How much do you like Go so far?
How much? I mean, I really like Go. It's again, I mean, it's well, sometimes when I talk about languages and then I start mentioning how long I've been using them, then people at some point are like, okay, you always say that any language you say, oh, I've been using it since blah blah blah, but it's actually true. I've been using Go before 1.0. That was
Okay.
way back, but for actual work, I haven't got the chance to use it as much. I did use it for some contracts, but it wasn't really as the main production language. It was more like scenarios where there were some tedious tasks to do by hand that I started to automate with Go. So I give you an example. One recent one that I did maybe a couple of years ago. The task that we were actually, it's that telco gig I was telling you about. In my team, in a team of 5 people, we had to maintain like maybe 15 microservices, with contract first, just like I showed, and it was Node.js based, right? So imagine we had to maintain the OpenAPI specs. We had to maintain the implementation of those specs in Node.js. We had to figure out how to do runtime validation with some crazy libraries. And then, since it's in the telco, like I mentioned at the beginning of the presentation, those things have to be compatible, because at a higher level, services that use our endpoints, they generate the clients. They don't write the clients by hand. They take in the spec and generate the clients, and then it runs. Right. So any tiny deviation, will break the system. So imagine doing development and doing all of those manual things at the same time. It was becoming very tedious. So what I did, I built a tool in Go to basically run some integration tests in the lower environment, right? So my tool will basically SSH into a host for Kubernetes, get access to the Kubernetes cluster, collect all of the specifications, and then start issuing calls and checking the results.
Okay, so technically like some kind of automation script that will check the cause and the data, right?
Yeah.
Okay.
So the cool thing with Go is that it has excellent support for concurrency. right? Because you don't want to run these types of tests, running one test at a time. It will take too long. So I will blast like, I don't know, hundreds of requests in concurrently to do all of that, and then collect the results into a dashboard so that we can just, from the dashboard, we can just click like run integration test, and then the graphs will be plotted to show what's red, what's green, and stuff like that. So if there's any red, it will be like for a specific API, and then we know that we have to fix it. So
Got it. Okay. Now that you mentioned that, I have something else to ask you.
Mhm.
Can you also include versioning on the, like, in the next presentation?
versioning.
Yeah. So that way,
the APIs, yeah.
yes.
Yep.
Oh, thank you.
Yep. Yep. Yeah. Anything else? Or maybe then I have a question for you guys. Did this presentation like give you some motivation to implement APIs using contract first?
I mean, from me, I guess since I don't do web development, so it's not something that I've touched a lot. But yes, it makes sense to do contract first. Then you don't have to like do the back and forth, right? When the contract is clear and it's signed, like any contract, then you can do the rest, right? Much easier. So I guess I'm sold on that, if I can say.
Yeah. Cool. And also another benefit of the contract first is that it's completely decoupled from the implementation. Once we have the contract, it doesn't matter if we build the actual server with Go, with Java, with Node.js, it doesn't matter. So implementations can be like swapped from one thing to another. So what's important is that as long as you have an efficient way to perform the runtime validation using that same contract, then you are good to go. So,
Hi, Benjamin.
yes.
Yeah, I have a question for you. I don't know. Have you implemented Go in a microservices project before? Probably if you have any documentation that speaks to that, because I think I might have to be considering Go as a second language I'll be learning for.
Go as a microservice.
Yeah.
Well, I mean, I've implemented a bunch of microservices, but not with Go per se.
Okay.
So just for the audience, there's a small nuance when we are talking about an API server and a microservice. So the microservice has some additional requirements in addition to an API. Like for example, if a microservice has to interact with data, it has to have its own data store. It's considered, for example, bad practice to have two microservices share a single database. Because the whole idea for that is that a microservice should be like standalone so that it can be scaled by itself. It should be completely isolated from any other microservice in the thing. And there are some additional things like related to logging, related to tracing the requests. Like for example, let's say in your cluster you have 5 microservices. microservices, and then the client makes an API call to one. And that one microservice needs to interact with the other 4 in order to fulfill the request, right? So there will be a bunch of server-to-server calls. So how do we know which one of those server-to-server calls belong to that initial client that called the first microservice? You know, because when there is a problem, someone needs to be able to look at the logs and see the request for from one specific customer and see how that request like flows throughout the system, you know, in a way that makes sense. So there's a lot more concerns for that one. It's
All right. Thank you. I appreciate that.
yeah, so I can look into that. I know how to build it, you know. I just haven't done it in Go. Most recently, I've done it in Kotlin, and I've done some in .NET, some in Java as well. I've done a bunch of them in Node.js. So I know how to do it. It's just a different language, Go.
Yeah.
What's for sure, Go has all of the tooling required to do just that. So
Yeah, that's true, including for GraphQL. I think it's GraphQL Go or something. Thank you.
yeah. That GraphQL Go it kind of sucks in my opinion because code has to be generated. I don't like to do that.
Okay.
Yeah, it's a maintenance nightmare. But anyway.
Is Go really that fast?
Yeah, I mean, if you compare it to things like any scripting languages, PHP, Node.js, you name it, Go is way faster. You know?
I asked the question so some that can hear it, some that you got it. That's why, because he is into Ruby on Rails, and then I'm trying to push us to go into Go. So that's why.
Yeah, but I mean, when you're building web applications, the concerns are a bit different because you can use a slow language, but it all depends on how much work you do. You know, if, for example, if you're serving pages that don't change, it doesn't make sense to keep querying the database and reprocess the templates and all that. You can just cache it. And if you cache it, that Ruby code or that Go code doesn't even run. So it doesn't matter. You know? But the parts where it actually runs, that's when the difference is noticeable. So let's see, this is Go. Actually, I can share this site. Sure. So this site gives you an idea of like how fast some code runs. Let me see. How do we do the comparisons again? I forgot. Okay, so you can see. Okay, that's a trivial thing, right? This is just doing hello world. Actually, let's pick something else. HTTP server. Okay, so for that test, I see the Go server run for 115 milliseconds. Let me see, is there Ruby somewhere? You see Ruby?
Ruby is so bad they didn't even list it there.
Not even there. But okay, let's compare the Go timing with is there C? Okay, so okay, actually let's pick this two. So nowadays, like people are crazy about Rust because it's fast and it's safe and all that stuff, right? And Rust is considered to run as fast as C. But in that case of HTTP servers, you see, Rust runs at 329 milliseconds. Go does 115 milliseconds, so faster.
Thank you.
Right? And look at C#. Compared to C#, you see how slow C# is compared to Go. C# is 698. Okay, so this is TypeScript, right? 694. So it's almost like six times faster, 5 or 6 times faster. Yeah, I mean, in terms of speed, Go is usually not the issue. So you can scale. I mean, you can scale quite big with Go before you. I mean, before it shows its limits. So basically, what I'm trying to say is that if you're using Go and you are worried about its performance, you know, it means that your app or your company is probably making multi-million dollars or $1 billion a year. So
you shouldn't worry about it if it's just your blog.
yeah, you're gonna have enough money to buy all the servers you want. So
Got it.
plus also it's very neat as a tool for doing DevOps or for building like servers, because when you compile it, it's a single file. You know, so your deployment becomes uploading that single file and then you're done. You know, so let me see. I can give you a better idea. So that was a long time ago. I think I still had I was still using shared hosting for some of my websites, and you know, shared hosting, the best candidate is usually PHP, right? You upload your PHP files and then they run, right? So since I can compile Go, I was compiling my Go app, and I was compiling it in a way that it will embed all of the assets. So all the HTML, all the CSS, all the JavaScript were inside that single binary file generated from Go. And then I was uploading that single file into my shared hosting behind Apache, and then it worked. You know, so no need to do FTP, all that stuff. Like, no.
Wow. Okay.
So it simplifies a lot of things because it just compiles to one file. So yep.
All right.
Yeah.
Thank you.
Yeah.
So do we know what the topic is for next week? I mean, not next week, sorry. 2 weeks from now.
Like in 2 weeks from now? Well,
Mhm.
if there are no volunteers, it's going to be part 2 of this one.
All right. We'll figure it out.
Yep.
All right. Well, thank you all.
Yeah, thank you.
Have a good weekend.
Thanks for attending.